All right, let's get started. It's really bright. Can you see the screen okay? Hopefully it's not too bright, not too dark. Okay. All right. Hello, everyone. Welcome to the data mining course. Just make sure you're in the same classroom. Okay. So 4502, that's the undergraduate section. 5502, graduate section. Okay. All right, so today just the first class, so we're just getting started. So I'm going to go over a few things. First, for those of you who don't know me yet, I think a good introduction will be helpful, and also like to learn more about the class. Checking. People in the back, hear me okay? Thank you. And then we'll just go over some administrative information regarding the course, a general overview of what we're planning to cover. And then we'll quickly talk about the policies. Those things, of course, you need to familiarize yourself with. Starting point, I'm Qing Lu. If you can pronounce my last name properly, that's fine. But if not, Lu is totally fine, okay? I go by Christine, so feel free to address me as Christine, okay? I'm a professor in the computer science department. So if you want to find me, email is probably the best way. We also use Piazza, right? If you are in Canvas, so you should have access directly to our Piazza course channel. So where we handle all the questions and answers there. So feel free to like use Piazza to contact me. But if you want to email me directly, that is the best way. I do check my emails regularly, so I'll try to get back to you soon, okay? And my office, if you haven't been to ECCR wing, I know it's not easy to navigate, right? So for students who are newer to the engineering center, it takes a while. So if you want to come to my office hour, just make sure you allow a little bit of time to find it, okay? So my background. So I did my bachelor degree in Tsinghua University. That's in Beijing, China. So after that, I went to Princeton for my graduate study, okay? Then since 2008, I have been here. So it's been many, many years now. I definitely like it here. And I really enjoy teaching this course because that's also related to my research, okay? So when I started learning computer science, that also when storage systems, okay, was getting like more popular. Because remember, everything you do, right, with your data, digital things, you need something to store it, okay? So, so in the earlier 2000s, that was like when we all of a sudden found, hey, we actually have a lot of storage. We can actually store a lot of information, okay? So data has really been the driving force. Like from my like career, so a starting point is about, okay, you can store data. So this is about managing, right? How you manage your data, going from megabytes to gigabytes, right? Terabytes of data. So when you have all this information, first thing is I want to store it, I can retrieve it later, right? So that's management. Then you want to share, right? It's not just for your own use, so maybe it's useful for you to share with your teammates or just generally share on the web, okay? But as you're sharing or you're using it, then you get to the point about, hey, I want to be able to search for information, right? And I want to be able to understand what's in the data, right? Because if you check your laptop, check your computer, you can probably easily have terabytes of like a storage space, okay? What do you put there, right? So, and then what can you do with the data, okay? So data exploration, that really becomes a point about, I have data, I have the way to store a lot of data, I have the way to share data, I have the way to do computation, right, with my data. But what do we do? Sorry. So when we're working with the data, there are two key metrics. One is the efficiency, one is the effectiveness. Okay? What kind of metrics come to mind when you talk about efficiency? Speed, how do you measure speed? Latency, right? How long does it take? If I'm sending a request, how long does it take for me to get something done, right? General latency, that's per request or per transaction. Also, you care about the throughput. What is throughput? So I'm not doing, say, 100 requests per hour, or I'm doing 1 million requests per minute, right? So that's about how long you can take. So it's in a more aggregated way. So when you look at the individual ones, you're talking about latency, right? But you're talking about in the aggregated way, it's a throughput. Both are important, right? Because you're working with your data. Sometimes you care more about the latency, right? It's about if I want to detect something, like say flagging something as a fraud transaction, right? You probably do it in the minute or in the sub-second, right? Right away, real time, near real time. That's the latency, okay? But sometimes it's more about I want to crank through petabytes of data. I don't want to do it fast, okay? So that's more about throughput, okay? So that's efficiency. What about effectiveness? That's a vague term, right? Depending on what you're looking at, okay? But it's generally about how good your results are, okay? So what metrics that may be useful when you talk about effectiveness or how good your results are? Anything that come to mind? Accuracy, right? If I make a prediction, how accurate it is, right? That's about how good it is, right? Okay, so you want to say I want to like, excuse me, make an accurate prediction. Then you're also talking about the false positive, false negatives, right? Those are like related but different terms, okay? But all those are talking about you're not just giving me a model or giving me a prediction. I want to have a way of measuring, right, the goodness of that result, okay? So you want the good results and you want it to be efficient, right? Those two, of course, are important. But throughout the semester and maybe as you work in your projects or like for your future usage of data mining, you will notice that those tools are all important, but they're important in different ways. And sometimes you have to do a trade-off, okay? Ideally, you want something that is both efficient and effective, but sometimes you have to make a trade-off, okay? And that's your reasoning about what was more important, okay? All right, so we say we want to be able to manage data, we want to be able to explore data. We care about efficiency, we care about effectiveness. How do we do it? Okay, because my background is in computer systems. So when I started, I was like, I was doing more like storage systems, and later we're talking about like wireless communication, and then when we do search, so it's a lot about systems design. How you can leverage your systems, whatever resources you have, right? So you can provide efficient and effective computation when you're dealing with the data. But then quickly I realized it's not just systems, right? You need good algorithms, okay? So same systems, different algorithms can probably make a difference. And sometimes it's about when you're designing your algorithm, if you know what kind of systems that you're designing this for, then you can choose or design the right algorithm that's more appropriate. For example, if I'm running this on a mobile phone, on a small sensing device, versus on a supercomputer or on a vehicle, it's very different, right? So there's a lot in terms of this kind of code design to some extent. You want to look at the algorithm aspect, you look at the system side, and then think about how you want to come up with a solution that works, okay? And then real-world data, it's always related to some application scenarios, right? I don't just give you data, say, okay, those are just bits. I give you 1 terabyte of bits, zeros and ones. Go figure out what you want to do. No, you want to understand what kind of applications, right? What kind of data I'm dealing with, right? What I'm doing this for. So you have a connection to your application scenarios, okay? So of course, application scenario is a very broad term, okay? I have worked with quite a few, but still it's a smaller set compared to other possible scenarios, okay? But generally, I have been looking at the scientific discovery. So there's actually a lot of very interesting data and challenging problems in the science discovery fields. The other one is ubiquitous computing. If you haven't heard about this term, it's just about people. We want to have computing, we want to have intelligence surrounding our daily lives, okay? So whatever data you can get or you can leverage regarding our daily behavior, then there's something we can do, okay? So those are the general application scenarios that I have been focused on. And I have this like interdisciplinary part, and that is also super important. As I said, right, your data come from very different application domains, and you want to make sure that whatever you're doing makes sense, right? So you will be working with experts or domain experts or people who know what kind of problem they have, what kind of solution they really need. They can provide some like expertise when you're trying to interpret your data or build your model, okay? So that's why I say this is a very collaborative setting, okay? So nowadays, like you may hear people saying that, oh, give me your data, I'll build a model for you. Sometimes that's work, but most time doesn't work, right? You cannot just throw your data over to the other side and say, oh, somebody will build a model and then you just use a model. There's a lot of interaction, a lot of kind of like discussion, exchange of ideas to make something work for a particular application scenario, okay? So just keep all this in mind as you're working with data. Because we're going to talk a lot about data and what we do with it, right? But some of those kind of high-level things, please keep that in mind. Okay, this is a busy slide, and I don't want you to memorize everything, right? There's no point of memorizing it. But it's really just to give you a bit of a like overview of different things that I do, but also why I care about this course and why I'm teaching this course, right? Because I do a lot of data-related things, but they are different flavors, okay? So what I call is more like a full stack, okay? So using my systems background, I don't know whether you can see maybe not, okay. Systems layer, this is where you get the data, where you manage the data. You do a lot of computation with it, right? So I've been focused a lot in terms of sensing. Okay, mobile sensing, wearable sensing, IoT sensing. These are the domains where you get a lot of data, okay? So how you take that data and connect to, of course, different usage scenarios, right? So we work with air quality data, driving behavior, okay? Earthquakes, also like group behavior, exercise, all kinds of things, okay? And there's actually a wide spectrum. So if you search online or just talk to people, you will see, like, depending on what kind of like sensing like modalities you have, you may be able to get a lot of interesting data and do something with it, okay? Once you have the data, you have a way of managing it, right? The algorithm is definitely very important, okay? There are a lot of focus on different types of algorithms. Nowadays, machine learning, deep learning, all those are very active. So I generally focus more in terms of spatial temporal data. This also relates to the type of like domain I work with, okay? So spatial temporal, just say you have things that are related to time and space. Can you think of some examples? What kind of data is spatial temporal? Yes? I'm sorry? Video. Why is that spatial? Video apparently is a time series, right? You have a sequence, you have time, but why is that spatial? Okay, yeah, so video data, you can view that as a spatial because you have, like within your scene, right, you have the different pixels maybe representing different objects and how they're moving. There's definitely spatial relationship, okay? Anything else? Another example, spatial temporal data? Yes? Climate data, okay. Can you be a little bit more specific?
Yeah, maybe like weather.
Weather, So weather data apparently is related to space and time, right? So here space is the actual physical space we're in, right? So like, I don't know, today weather is good, right? But when you have thunderstorm, you want to know like where it is, what time is it happening, okay? So that's the space and time information you can leverage, okay? Traffic, right? Let's compare another example, okay? Or you're talking about the sales data of different, like say a chain store, right? So you care about like how, like when people are buying what kind of things, in which stores. So there's also actually quite a bit of spatial temporal information you can leverage, okay? And a lot of times it's about, I also like data fusion because it's about the modality, the different types of data, right? So we already mentioned video data. We mentioned like weather information, sensor, right? Sensing data. So they're very different. And sometimes it's actually very useful for you to be able to combine different types of data, okay? And it's not like straightforward, right? Many times, oh, I can just concatenate all the information, fit into a model. I have like some kind of like a predictor or something, right? But many times, if you know what kind of data you're dealing with, there are different ways of handling the data, okay? So how you fuse them effectively is also an interesting problem. Anomaly detection, we're going to talk about this a little bit later in the class. That's about outliers, okay? This is just say, as the name suggests, anomaly is different from the norm, right? But how do you detect it, and why is that even useful, okay? So we'll cover more later, okay? Related to that is a recommendation, okay? This also is about when you leverage a lot of data, you're trying to identify most useful information, right, and make recommendations in very different scenarios. Okay. Application-wise, I don't need to go through all that, but I'm happy to talk about more if you're interested. But I would just want to mention that there's really a lot of domains with a lot of data. Okay. But working with the domain experts, that's when you can understand the problem, understand the data, and then come up with a solution that's actually reasonable for their needs. Okay. I hope I said probably enough about myself. So now let's do a very quick show of hands so I can get to know a little bit about the class. Okay. So we have 4 sections, right? But I think the in-person, I don't know. I can check. Okay. So if you're in 4502, section 001, please raise your hands. Not many. Okay. Okay, 4502002. That's the online section. Actually, I don't expect many to be showing up. All right, 5502001. Majority, I guess. Okay, thank you. All right, 5502002. A few, okay. So if you read in my syllabus, right, so 001, that's the in-person. So I expect you to come here. But for 002, we also have, if space is available, you're welcome to come in, okay? But then we also will have the recorded lectures. So I'll talk a little bit later. So you can actually review the material later on. Okay, related to that degree program, I know I have undergraduate students. I want to check how many of you are CS majors, BS-CS? Okay, majority, okay. So this gets a bit easier, so it's a bit harder, okay. So any other majors, if you'd like to raise your hand and just briefly mention which major you're in.
Information science.
Information science, okay. Other ones?
Computer engineering.
Computer engineering, uh-huh. Any other ones? No? Okay, all right. So I think we're definitely limiting the enrollment. We used to have a wider variety. I used to have people from business, physics, and other disciplines. Okay, so I kind of got this question already from the degree program, but maybe just quickly, PhD students, a few. Okay, master's students, quite a few. Undergrad students. All right, thank you. Okay. Next, programming language. This is about personal preference, but generally in data mining, we do use Python a lot, okay? Some of us use R regularly, okay? C, C++, and Java, they are still useful, but they're maybe not used as much, okay? So maybe, again, quick show of hands. How many of you are comfortable with Python programming? Okay, all right. How many of you use R? A few. Okay, MATLAB? Okay, Java? Okay, C or C++? All right, okay, thank you. Cloud computing. This is not required for this course, but for your course projects, if you're interested, you can use cloud platforms, because especially for larger scale computation, okay? How many of you have used AWS? Okay, Google Cloud Computing. All right, Azure. Okay, some other ones? A few?
Heroku, and there was one more platform I've used 6 to 7.
Okay, all right, thank you. Okay, social networks. Okay, why do I ask this question? We actually do a lot of research with online social media data. Okay, so I'm just curious in terms of what kind of social media people use. And I have to say things have changed quite a bit during the past few years. Okay, starting point. How many of you use Facebook? Okay. Twitter is not really there. Twitter. How many were more active Twitter users? Okay. Reddit. Okay. Instagram. Thank you. Okay. TikTok. Some. Okay. Other ones. Discord is not. Okay. Candy. Discord. Maybe I'll ask that as well. Okay. Thank you. All right. So if you use some of the social media, maybe another thing you can start thinking about what kind of data is available there. what kind of things that may be useful you can leverage to answer some interesting questions. Okay, that connects to the last question here, types of data. Okay, so maybe I just like, if you can volunteer, just talk about some kind of data you're really interested in. Okay, so anybody want to start? Just, yes? Video? What kind of video data? I'm sorry? Point of view? Okay, all right, but for what purpose? What you can do with it? Robotics, okay? So it's like for the purpose of a robotics navigation or operation, you have this video data, continuous feed, but it's really the view from the like robot, right? Okay, all right, that's okay, good example. Any other things? Anybody? Yes?
Healthcare data.
Healthcare, okay. Anything particularly?
Like diseases for classification.
Okay, so disease. Are we talking about like cancer? Okay, image data or medical record or? Images. Okay, so medical image data, okay, for say cancer detection research. Okay, good. Yes?
Data related to traffic.
I'm sorry, traffic? Traffic data?
Yeah.
Okay. What do you do with it?
Like detect in terms of whether safety, traffic safety analysis, and in general the traffic system understanding how many cars or how many buses and everything are going at per second to determine the signals and everything according to that.
Okay, yeah, traffic data. So apparently, like if it's a bus, like collected this actually there's also a difference whether you're collecting data from the individual vehicles, right? So there's like a telemetry data, right? Also, you can have a more of like say I think a lot of like Department of Transportation they have like infrastructure, right, on the road so that they can measure. So there are different types of data, but the helpful thing is that yeah, safety application scenarios or congestion or I don't know like emergency, yeah, rerouting whatever. Anything else? Yes? Remote sensing data, okay. Anything in particular? For weather and climate usage scenarios? Okay, all right. Yeah, so remote sensing data is actually widely used, right? Some other example may be related to over here, wildfire, and also actually for agriculture usage as well. You may be able to leverage that to understand the land use or even detecting disease, right? If you can get to that kind of precision. Anything else? Yes? Financial market data, yes. Anything more particular, like time series or?
Time series regarding like the ETFs and the REITs funds and whatever that I can do with the REITs plus the exchange traded funds, whatever data that I can get and then I can predict like how is it going to perform in the future, like 1 to 3 and 5 years.
Yes, so for financial data, there's actually a lot of information you can gather, right? Time series data being definitely a big part of it, but they can also leverage, I think I have, like previous years, we have students combining social media data to understand like the sentiment, right, related to certain companies' products, right? But also like finance report or other things, right? But there are a lot you can do, and there's of course big value in that one. You can make better prediction than others, so you're probably talking about a lot of money involved. Good. Anything else? No? How many of you deal with emails? Do you work with the emails on a regular basis? Okay. Do you know how many emails people send on a regular, like on a daily basis? How many do you send? Hundreds? Less than 100? More than 100? All right. So this actually also gets to the scale, right? So think about it, because when you talk about data, this could be something that, yeah, you can find on the web or like from your job or something. But a lot of times the data is your own data you interact on a regular basis, right? So, and also you can think about how you use that information, right, for some analysis, okay? All right, let's switch gear a little bit. So we'll talk about the course, how we're going to manage this course, okay? So as we have already said, we have 4 sections. It's combined, right? Undergrad, grad, combined, okay? So this is a classroom. I hope you find it Took me a bit navigate. It was so busy on the road when I was riding my bike over. So just plan accordingly so that you have enough time to get here. So we do have the 002, which is the online section. If you see, like in Piazza, we already had a question about the remote section. If you remember, we had these three terms: in-person, remote, and online. Okay, so we got rid of the remote one. So that basically means that we don't have live Zoom participation for the class. We still have the other two, so either come in person. And right now, our lecture is being recorded live. And usually it's available in Canvas. So you go to Canvas, top left, there's a menu section called lecture videos, okay? And all of you can just go in there, you can access the recorded lectures, okay? So usually it's available shortly after the class is done. So I would say give it an hour or two, you should have it. Okay, all right, our textbook. So this is the textbook we have been using for many years, and last year they finally came up with a newer version. I'm glad with that, because the previous third edition was from 2011, so it was pretty old. So they have updated, so I didn't require, like I said, if you go check, I'm not requiring the latest edition. It's good to have, but you don't have to buy it. If you have an older version, that is fine. Most of the materials are still similar. They did some polishing of some of the text, and also they added a deep learning section, okay, a chapter. So there's no big difference. So you are okay to use the older one, but if you're going to get a new book and for data mining, this is definitely a very good textbook I would recommend, okay? Website, by now, hopefully all of you have logged into Canvas to check out our course material. That is where I'm going to post all the course-related information. So the lecture slides, the lecture videos, assignments, submissions, all that will be posted there, okay? Just make sure you check it, familiarize yourself if you're not already familiar with Canvas, okay? Just know that is where you'll find all the course-related information, okay? And through Canvas, or you can do separately to Piazza. But Piazza is what we're going to use for all the course-related, like Q&A, okay? So if you have questions, post it there, okay? So myself and our TAs were monitoring that, so we'll just try to respond that to you very quickly. But also know the one thing I really like with Piazza is that you can help each other, right? So if there's a question that somebody already figured out, not about homework questions, answers, okay? But if it's something like you know and can help your classmate, feel free to post it, okay? But do you understand, yes, so Canvas, Piazza, these are all for course related, especially later on when we get to course projects, right? These are individual group contributions. So I ask that you do not share the information outside the class. Okay, hopefully by now you know me. We have two TAs for this course, okay? So Mosena Ashraf and Julia Romero, so they're both PhD students in the computer science department. So they have taken my course before. Julia has been a TA for this course before, so they're familiar with the content. So they will be very good resources if you have questions. So I think I have my other slide. So grader, we are going to have one grader who's doing the grading of the homeworks, okay? So she will not be interacting with us directly. But if you have questions, go through the TA, because myself and our two TAs, we have office hours, okay? So you don't need to memorize this. This is all in Canvas. If you go into the syllabus, it's listed there, okay? So each of us, we have regular office hours every week. Our office is meant to be in person via Zoom, so you can join via Zoom if you need to, okay? So if you check out the specific timing, so for me, today, later on, 6:30, I have a Zoom only, because that's only after hours. I'm at home. But I'm offering that because I know some of us either have a day job or it may be inconvenient during the day, so I generally offer this evening session, but that one is Zoom only. So you don't come to my office, I will not be there. But for all the other office hours, we're going to have also in-person, okay, and the Zoom option. So you can check the time and decide when you can make it, okay? If you look at the location, so this is my office, 1B24. The TAs will be holding their office hours a little bit down the hallway from my office, okay? It's in the same wing, so make sure you can find it. If you find my office, you just walk down the hallway, you can find the TA office hour room. Okay? Any questions so far? Good? And the slides will be posted, so you don't need to memorize or note down this. Okay, this will be available online in Canvas. All right, course overview. Why you're taking this course, or why I'm teaching this course, right? So with my introduction, you probably see, right? I really like, I work with a lot of data, and I really see the potential and the value and the challenges, right, of working with a lot of data, okay? So when we talk about the data mining, the starting point is really that you have a lot of data, right? When you have a lot of data, either you see that as a burden, right? I need to find a way to store it. I need to maybe do backup. I know it may be challenging to find things. But really, I will bring value out of it, right? Because there's a lot of data being generated already. Either it's freely available, it's reasonably easy to use, or you can collect the data that can help you to do something, okay? So that's really the starting point, right? We see a lot of data, that's a norm, and more data being generated, okay? So we want to be able to take advantage of this, right? Use your data, okay? So we say generally data mining is about finding interesting patterns from data. That's easy, right? But then define interesting. What kind of data we're dealing with, right? So earlier, as we're talking about the different types of data, we already kind of get into a bit of it, right? Because your question is not just say what kind of data you have. It's more about what you can do with it, right? Because why do I care about a particular data set? Why do I want to spend my time and the effort of working with the data set? It's because ultimately I want to bring value out of it, right? Okay. So earlier, some of the driving forces, right? This is really in the kind of finance or the general business markets. They have a lot of data naturally because whenever you buy something in a store online, there's some kind of record, right? Showing that, okay, some customer purchases something from this particular, at this time or through this particular platform, right? Okay, so at the very beginning, it may sound just like a recording because they need their bookkeeping anyway to know their sales information. But then you say, okay, what can I do on top of that, right? What they're doing, okay? So I'll pick Amazon as a starting point. How many of you have used Amazon to buy something? Okay, so when you go there, of course you search, right? Either you know exactly what you want, you go there, find, and then you're done. Sometimes you're browsing, right? So I need to find something, but I want to check which one's good. So what kind of information is helping you there for you to decide what to buy? Price. What else? Reviews, right? Reviews is very useful. That's good data, right? That's actually a good way of using the reviews to help you to make the decision. What else? Suggestions, recommendations, right? So Amazon actually behind the scene, actually all the other business as well probably, they do a lot of suggestions, recommendations because they want you to buy more, right? So when you go there, right, you want to either you know exactly what you want or say you're looking for something you want to buy, so you're leveraging a lot of information on the platform, and then you're utilizing maybe either intentionally or unintentionally, you have information that can help you to make a decision, right? And that may be beneficial for you, of course, I hope, right? That you got something you want at a good price, but also that could be something that is helping for the company because they have more sales. And the sellers, of course, I hope, right? So as you can see, there are different parties. They're all on this platform, utilizing a lot of information, trying to accomplish certain goals, right? So that's one example. But there's a lot, right? Netflix, if you use Netflix, they use a lot of recommendations or prediction because they need to understand or they want to look at your behavior and then be able to allocate the resources depending on what is most popular. Or I know you're watching this episode, then very likely you'll be watching the next episode. Or if you're watching this one, then the other one may be very relevant. You may want to watch it. So this is both in terms of the experience of the users, but also in terms of efficiency of the support. Okay? That's in the market side. Let's check another thing. This gets more of the medical, right? Earlier we were talking about the medical images, okay? Known applications, there's a lot also those are still kind of finance sector, right? But a lot of times you're trying to do classification clusters. So those are terms that we're probably mentioning many, many times throughout the course, okay? So many times, generally with data mining, when you talk about patterns, it's about things that are similar versus things that are different, right? Because if you know things are similar, then you can leverage, right, what is similar about it, and then make predictions, make recommendations, all that, right? Or if you have a way of separating or differentiating things, say this is for example, no application. You talk about like safe, or this is or risky, like investment, or the medical diagnosis, right? Cancer or not, which stage it is. You're trying to look for differences so that you can separate things, right? Another one, time series. We'll talk about time series earlier, right? So traffic, weather, social network. Why is social network time series data? What do you do on the social network? You post things, right? So you may post something, say on Instagram, and then there'll be comments, right? And then maybe like people continue sharing it. So you actually have a time series of how things are progressing in the social network. Why is that useful? You can figure out what's popular. You'll predict what will become popular. Something may become viral very quickly versus something like if you want to promote your music or your product, then you will identify there's actually some very interesting study to say there's a particular time for your posting. For example, you post late in the evening where a lot of people are actually on the screen, so they'll get it right away. And also weekend, so there was something, again, all varies, but you can actually look at the time series to see what is a good time, what is a better time for you to figure out how things would get propagate or get responses on the social network. Financial stock we talked about earlier, that's also very important for you to see how things are progressing, right? So you can see, right, those are just examples, okay? But naturally, whenever you pick up one type of data, given the application scenario, given the context, you can probably ask some very interesting questions about it and think about how you may use that data for some value, okay? So what are we going to cover in this course? Okay, as I said, this is about data mining, okay? So we are talking about concepts, right? What do we mean by data mining? What are some of the core concepts already mentioned? Clustering, classification. We'll talk about the similarity. We'll talk about the separate, dissimilarity. So all those are things. But always think about effectiveness versus efficiency, okay? So what we want is discovering interesting patterns from large amounts of data, right? Data, patterns, okay? So you're mining patterns from data, okay? But then how do we do it? Okay, so we'll cover quite a few items throughout the course, okay? Those are really some of the core, steps and the main pipeline when you're talking about the data mining, okay? Because at the very beginning, say I have data, right? First place is how you get the data, what kind of data you have, right? But then it goes through maybe this black box, and at the very end, you get something that's useful, interesting, okay? So we're trying to figure out this thing within this black box and how we can do a good job, okay? So we'll be covering quite a few of those content. Here is a bit of kind of schedule. So this is also posted in the syllabus, okay? This is a tentative schedule. But typically think about it. We have one semester, that's 16 weeks total, okay? We have 1 week, that's a fall break, okay? So minus that, we have 15 weeks total. We're in week 1 right now, okay? So okay, you don't need to memorize those terms. We'll go through this. But earlier, we're talking about really the pre-processing, kind of warehousing is about managing or preparing the data for analysis. And then later on, we have some of the core steps. Pattern mining, right? We're talking about finding interesting patterns. Okay, we're talking about the classification, clustering. So those are all core concepts, the techniques, because as I said, we're trying to find similar things versus the different things, right? Classification is about you have different classes, you are separating things, okay? Clustering is about finding classes that are similar within the cluster, different across clusters. So a lot of that is about separating things, finding similar things, okay? So we'll talk about the project later, okay? But we are going to have a few milestones for the project as well. Just keep in mind, we do have one exam. That's the midterm exam, okay? So we don't have final exam. And the midterm exam is not exactly mid. It's week 10, okay? So that's when we have finished the the main concepts of this course, okay? After we're done with the midterm exam, then we have most of the time more focus on the course projects. Because by then, I hope you have learned enough, so now you can do something hands-on, okay? All right, so that's the high-level schedule. Policies, you've probably seen this from other courses you're taking, because there are some standard statements we're using from the campus, okay? If you have done it already, that's fine, but still doesn't hurt to go through it. Make sure you have everything covered, okay? If you're new to this, please just spend some time. It doesn't take a long time to read it, but it's very useful for you to be aware of it, okay? So general thing is that, one, classroom behavior. I do want you to respect the time of everybody, right? So in the class, I do ask quite a bit of questions. I actually welcome questions or discussions, okay? But just nothing disruptive, right? If you have any particular issue or things you need to talk to me, feel free to talk to me, but just don't disrupt the class. That's one thing, okay? Any other things, if you need any special recommendations, talk to me, okay? All right, so one thing I want to specify also every year is that we do have assignments that you need to work by yourself, okay? And then we have the course project, that is a group project, okay? So by default, you should work by yourself. If you're not sure, work by yourself, okay? And then if it's a specific set, yeah, this one you should work as a group, then you can do it. If you're not sure, check with me, okay? Because it's very important that you acknowledge help you received, information that you use online, and then really claim what is yours. That's important, okay? So especially with nowadays data mining, if you go online, you can easily find a lot of information. Okay, a lot of information. You can take a probably existing source code or a tool, a results, and be done with that, right? But think about what's your contribution on top of it, right? We're totally fine. You're leveraging whatever is already available. We don't need to be reinventing the wheels, okay? But think about what is yours. What is your contribution, okay? All right, grading. Homework, starting point. Since we have undergraduate section, graduate sections, so we are going to do separate grading, okay? So there are assignments and there are requirements that's more required for the graduate students and optional for undergraduate students, okay? That's starting point. But then we have this core components, homework assignments. We're going to have 5 homework assignments, most in the first few weeks, okay? First one will be posted next week. It's due the following week. So we have a bit of time to get started, okay? But we have 5 homework assignments. This is something you should work by yourself. And then we have 1 midterm exam, right? That's in week 10. So that one, of course, work by yourself. We'll figure out later how we're going to manage, because we do have online sections. So we'll figure out how we manage the exam with the in-person setup. And maybe I'll add maybe a Zoom session. Okay, but I'll manage that. I'll talk about that later. But if you have questions, please talk to me. All right, course project. That's actually a big component. This is something I really ask my students to do every year, because I really think it's something interesting to do and important to do for you to just try it out, right? You'll be sitting through lectures. You're doing some kind of mini programming assignment that's for the homework assignment. But that's very different from working on a project, an actual data mining project. You're basically doing that from start to finish. You come up with your own ideas, you work on it, and then you present your results. So I feel that's very good practice. It's not easy, okay? But I hope you find that valuable, and it's really good practice, okay? Then late submission. So generally, all the materials and the due dates will be posted in Canvas, so make sure you check it regularly. I'll also remind people about which assignment may be due, when you need to submit what. Okay, make sure you stay on top of that, okay? If, as I said, if any special situations you need any accommodation, talk to me ahead of time. By default, if you're late, then we basically say we'll accept it up to 2 days past the due date, okay? And there will be penalty on it, okay? All right, so I'd like to talk a little bit more about the course project. It's 40% of the grade, so it is a big one, okay? What do I want you to do? First one, it's a self-contained project related to this course. Okay, it's a very broad description, right? Of course, we're doing data mining, okay? So something related to data mining, okay? But the thing is, I'm not giving you a project. I'm not giving you a predefined data set. I'm not giving you a predefined list of tasks. And I'm not using some kind of benchmark results to test how good your results are, okay? Because I feel a very interesting and a very challenging part with the data mining is asking the question, right? What is worth doing, okay? Find a problem that is worth spending your time on and have a way of figuring out what question you want to ask, how you do it, and whether your results make sense, it is valuable or not. Okay, so just try do the whole thing. Okay, because of that, right, I do recommend group projects, meaning that find your team. Data mining is particularly interesting and challenging because if you're just sitting down by yourself, like just working with a lot of data, sometimes it gets boring, and you may not have like many ideas. Okay, I always find it's interesting when you talk to people because people all have very different perspectives. We have different backgrounds, right? Your friends may be very really into some kind of say sports, and they have a lot of domain knowledge you can leverage in your process, right? Or if you talk to your parents, or even a small child, they may have some ideas that may actually inspire you. Okay, so talk to people, find your teammates, but still talk to even beyond your teammates. Okay, group size I usually recommend 3 to 4. Okay, over the years I've had students who say, for my project, or this is really my research, the data is confidential, or my schedule doesn't really work well as a group project, fine, talk to me, right? We can check the specific situation and see whether that's meaningful for you to do it alone or with a smaller size. That's possible, but please check with me first, okay? 3 to 4 is a reasonable number because it's manageable without being too big. I think the largest size, group size I had before was 6. But that was a big group. But the group of people that already know each other well, they had they had a very good schedule to monitor everybody, so that worked out. But typically, you don't want to have too big a group. It's hard to manage. Okay. And also, we can have students from different sections: undergraduate sections, graduate sections, in person or online. That's all fine, as long as you share the interest, as long as your schedule works out. That's totally fine with me. Okay. Starting point, though, is really about your idea, right? How do you start? Okay, so now think about the setup. You just think about something you're always interested in. You always wondered certain things that may be answered or help you to answer using some kind of data. That's the starting point. Because I think the project will be a lot more interesting if it's something that you are interested in or you always wanted to learn more about. Okay? So start with that, okay? Because in the previous years, I usually have students say, oh, can you give me a list of ideas? I can, but I don't want to limit you to that, okay? So please, just think about that first, okay? Feel free to come to our office hours, just do some brainstorming session. We're always happy to talk about it. Every year, I really am amazed by the ideas that came out from my students. There's every year I learn new things, okay? Or even for the same type of problem, there are different ways to do it, okay? And that's really interesting but challenging, but do it. This exercise is very useful for you, okay? All right, so let's do that, okay? And then start thinking about, so even right now, based on what we have talked about already, or think about what kind of data you may have access to, right? That's important, right? You want to be working on a project that you can use the data. If you say, I want to do this, but I don't know how I'm going to get the data, sorry. You may have brilliant ideas, but without data, you cannot do your project, okay? So in the previous years, I have had to discourage some very interesting ideas because the data was just too challenging to get, okay? We only have 15 weeks, right? So also keep that in mind as you think about what data you can use, what kind of projects you can do, okay? I'm not too worried about the scoping of the project, because sometimes I get questions about, oh, what is a good enough project for the course, okay? It's hard to say upfront, usually. I would say you start with the ideas and start with a list of things you think you can do, okay? Throughout the process, you actually want to have a longer list so that you have more ideas you can explore. Okay, you don't need to finish it, and usually, of course, we don't finish it, everything, okay? But throughout that process, you have like a bigger picture of what can be done, and then you can prioritize based on your findings along the way, okay? So that's a better practice than say, oh, the professor said, yeah, 3 tasks is sufficient, so I'll just come up with 3 and stick with it. Because I cannot do that, okay? I usually think it's a lot more interesting. You come up with a 5 and then realize, oh, those 3 are mostly interesting. Or say, I came up with 10, I realized, okay, those 3 are absolutely not doable, or they're not interesting, okay? But try to come up with more ideas, and then try to prioritize, okay? All right, so that's with the general setting of the project. Any questions? Good? How many of you think you already have an idea you want to explore? A few? All right, okay, keep thinking. All right, so a little bit more specifics. This is the timeline, okay? As I said, this is a course project, so that does mean that we're kind of spending the whole semester to work on it, okay? Of course, let's say, okay, like we're just in the first lecture, I haven't started learning yet, right? What do? That's why I say we have the proposal. That's week 5, okay? So by the time of the proposal, you should have a general idea. Okay, you don't know the techniques yet because we may not have covered the particular technique you want to use, right? But you can start with what kind of problems is of interest, what kind of data or data sets you think you already have access to, or you're very confident you can get the data. You have your team, okay? And you have some general ideas that, okay, with this data set for this problem, we can do this, okay? So that's the general idea, okay? So you need to have a reasonably good motivation. Why do you want to work on this problem, right? Literature survey, okay? If you don't know this term, this generally just understand what has been done before, right? Because we don't want you to be just like doing something or say, I found this, but realize that, oh, people already know. That's already common knowledge, right? Or you want to build something, but you want to build it upon what has been done already, okay? So literature survey is just a way for you to like search online or check out the related papers, whatever, talk to people, so you find out what has been done already, okay? Of course, this cannot be exhaustive. You may not know everything, but a general search should give you a good idea in terms of what has been done, okay? Proposal work, as I said, like in this case, like when you're doing the proposal, this is only week 5, so we don't have everything figured out, but just a list of what you plan to do, and with some reasoning why you want to do it that way, okay? So what kind of questions is worth asking? You may want to get this data set to do this on top of that, or you want to get these 2 data sets to do some kind of comparison. So have some general idea, which can be refined later. But by the proposal stage, as I said, like, don't worry about having everything figured out. You will not. Nobody can do that, okay? It's more about, I want to set up my problem. I have some general understanding of the problem setting. I have some general idea of how to do it, okay? But evaluation. This is something you should be thinking ahead of time, okay? Instead of saying, oh, when I'm done with my project, then I will do the evaluation. I can report the results. Because evaluation is a way of saying whatever you have done within this black box to demonstrate that you have found something useful, interesting. What kind of things do you care about, right? So if I'm doing this kind of like the medical image thing for cancer detection, maybe accuracy, right? Okay, so that's okay. If I want to show whatever I'm doing, I want to see what I can like accomplish. So like what kind of accuracy I can accomplish, false positive, false negatives. Or if I'm trying to come up with a more efficient way of doing something, like say for outlier detection, fraud report, you can say, okay, my method with this pipeline, I don't know how I'm going to do it, but to evaluate my success, I'm looking at the latency. Like instead of, let's say, 1 minute, can I do better? Okay? So think about the metrics, right? The setup of your evaluation, okay? So that you have a way of claiming success or failure. That's fine too, right? But you need to have a reasoning about whatever you have done is meaningful. Make sense? All right? Okay, milestones. This is just keep your like on track in terms of the weeks. I usually do that by weeks because we only have 15 weeks, right? By week 5, you basically talk about 10 more weeks. So just to have that in mind, and everybody's busy. You probably have other courses that may have their schedule. So just keep all that in mind as you're working. Say, okay, I know this week I'll be very busy. I cannot do much, but I should have this done by this week. So just have a bit of kind of general understanding of what is needed and how your schedule would look like. And as a group, make sure you coordinate, right? Sorry, I skipped one. Let me see. Okay, and then we have the checkpoint. So why do I do a checkpoint? Why don't I just say, give me your proposal, and by the end of the semester, I'll check your final result? Checkpoint is when we want to basically see your progress, right? That's week 11, okay? That week is, I think, so 2 weeks before the fall break. So that is when we're going to see where things are, okay? Because by then, it's kind of 2/3, right, of the semester. So not hopefully, I will expect you to have your data. If you don't have your data by then, that's a big trouble, okay? You have your data. You probably have done some preliminary analysis, preliminary implementation of whatever you are trying to do. So we want to just see how things are, okay? Either say things are progressing as planned, great, right? Then we say, okay, with some feedback, say I'm just continue. I should have this done with a good success or a good finish by the end of the semester, great, okay? But many times there'll be changes. Either the data doesn't look like, or I hope it's not that I cannot get data, or my data are totally lost because my computer crashed. That can happen. Just to make sure that try to minimize that risk. But by then you could either say, okay, we actually want to switch our project. We want to change it to a completely different project. Fine, you can still do it. Have time, okay? But of course, we try to avoid that. But if you need it, you can do that. In the previous year, we have had groups had to switch, okay, due to whatever reasons. But that is still doable. But a checkpoint is probably the last chance for you to think about the changes. Either completely change the project, some adjustment to your project, or maybe leverage another data set or reshuffling your priorities in terms of task list. Those are all fine, okay? But that is when we just want to see where things are, anything that we can provide feedback, help in terms of really a good finish of your project by the end of the semester, okay? So that's week 11. And then final project has week 16, so last week of the semester, okay? As I said, we don't have a final exam, so this is really what you'll be finishing, very last piece of your submission for this course, okay? By then, we expect a finished project, okay? Even then, you may still have tasks that, we started with say 5 tasks, we only finished 3. Fine, right? We want to see what you have accomplished, okay? So we'll have actually more discussion. Right now, you don't need to memorize this. Many of those will become more meaningful by the time you're writing your actual report, okay? But that is about reporting what you have done, okay? As I said, with the data mining, ultimately you want to be able to say that I have done this, I have found something, I have built something, and this is why it's useful. Right? So you want to show that rather than say, I took this data set, I did this, and this is the list of the results. I give you 10 pages of images. Say, go check. That's not data mining. Data mining, ultimately, you want to be the person taking all the results and identifying the most valuable results. Right? You're not just doing this, purely engineering work. You're producing a report, and you're done. Okay? You want to be the person analyzing the results. You want to be the person summarizing the work and be able to highlight what is your contribution. Okay? So keep that in mind as you because always just say, I did this, but why would people care? Right? All right. This is, again, some of the details in terms of what you need to capture. We're actually finishing early. Okay, so we'll be starting chapter next lecture, so that's Thursday, okay? So if you haven't started, I would just suggest start reading the textbook, okay? Just get familiar with yourself, and a few quick reminders. Canvas, syllabus, Piazza, starting reader chapter 1, and start thinking about a course project. Okay, so that's all for today. We'll finish earlier. See you on Thursday.